In this section, we're going to talk about algebra and what it is and its use for problem solving and for expressing mathematical ideas. So basically, you can think of algebra, at least at the college level or below, so not at the kind of university level. Algebra means something different to mathematicians, but let's not worry about that. We can think of it as using rules and operations to solve for unknown quantities. And of course, we're thinking of our unknown quantities as variables. And so we also have numerical expressions. And they have just numbers in it, so no variables. So we have algebraic expressions, which have variables. Maybe I'll write that as well. So these have variables. All right. So let's do kind of a quick example, and we'll see what's happening here. So let's do the following magic trick, if you will, to kind of see the power of algebra. So I want you guys to pick a number. Pick a whole number between, let's say, between 1 and 10. This will work for any number that you like, but just to keep the calculations easy, pick a number between 1 and 10 and follow along. So the first thing I want you to do, I want you to add 7 to that number. Okay? And then once you add 7, I want you to multiply that new number by 2. Then once you do that, I want you to subtract 10 from your new number. And then once you've done that, I want you to divide by 2. Okay, so once you've taken that number and divided by 2, the next thing I want you to do is I want you to add 3. Then once you've added 3, I want you to subtract the original number you started with. And I will say, usually in a class setting, I'll ask everybody, oh, what number did you get? And everybody will get the same number, and that number is 5. So I bet if you followed these steps, you got the number 5. Wow, I'm a mind reader. How did I know you were going to get 5? Well, if we write down what's happening in algebra, it's a lot more clear. So let's go ahead and do that. So let's pick a number. Let's call that n, because n could be any number, so we can't actually pick one. So I'm going to use a general n. You'll see that no matter what number we picked for n, we'll always end up with 5. All right? So we're going to take n, and we're going to add 7 to it. So we get n plus 7. So if our number was 1, we would have got 8. 1 plus 7 is 8. If our number was 6, we would have got 13. 6 plus 7 is 13, etc. Okay, now we're going to take the number n plus 7, whatever that is, and we're going to multiply it by 2. And if we simplify this, let's expand across. 2 times n is 2n. 2 times 7 is 14. So we get the expression 2n plus 14. We keep going. We're going to subtract 10. So we get 2n plus 14 minus 10 is 2n plus 4. Now we're going to divide by 2. And I'll write this in fraction notation just so it's a little bit easier to see. So we get 2n plus 4 divided by 2. And I can split that up into two fractions. 2n over 2 plus 4 over 2, which is 2n divided by 2. You can see that the 2's here cancel. So we'll end up with n, and 4 divided by 2 is, of course, 2. All right, so now we're going to take n plus 2, and we're going to add 3 to it. That gives us n plus 5. And then finally, we take n plus 5. We subtract our original number, which was n, and we get 5. And notice that that 5 does not depend on what we picked for n. In this last step, when we subtract the original number, we're canceling out what we originally picked, and we're just left with this 5 here. And if you see it algebraically, it's very obvious what's happening if you just do it step by step. It's no longer magic. So let's get some practice translating some word problems from the language of English to the language of algebra. And this is, of course, a very important skill. I think it's important. I want to make this note here. And we're going to do a lot of this. There's a lot of language in mathematics. So mathematics, let's say, is approximately equal to a language. There's a lot of problem solving and everything to go along with it. But the language of algebra, and the language we write things down in, is a really powerful and important language. And it's one of those things that you have to study like another language. You just have to do it a bunch and practice and get fluent and comfortable in expressing yourself mathematically. So that's what we're going to do now. So I will give you a few phrases, and then let's see if we can write it in the language of algebra. So the phrases are, so here they are. The first one, there are 10,000 more students at U of M compared to U of W. So let's translate that one into mathematics. So the first thing we need to do is we need to decide what the quantities we're interested in, and we're going to define them as variables. Well, the two quantities that we're interested in are the number of students at U of M or University of Manitoba and the number of students at the University of Winnipeg or U of W. So let's define those. We can use whatever letters we like. It doesn't really matter. But I like to choose letters that kind of remind me of the concept that they stand for. So I'm going to define M. And remember, this colon equals means that I'm giving the name M to the following concept. And that concept is the number of students at the University of Manitoba. Again, don't just write University of Manitoba. You're not being specific enough about what your variable is standing for. You need to say what your variable stands for precisely. So it's really important to say number of students at the University of Manitoba and not the size of the campus or anything like that. The second is, of course, going to be W, which is going to be the number of students at the University of Winnipeg. Now maybe I'll erase this 2 here. I don't know why I put that in. Sorry about that. Okay, so we have our variables defined. Now we just need to write our expression. So there are 10,000 more students at U of M compared to U of W. Well, that means if I take the number of students at the University of Winnipeg and I add 10,000, I should get the same number as the number of students at the University of Manitoba. Now, maybe some of you might have written something different. Maybe you've written m minus 10,000 equals w. But you can see that these are the exact same expressions. If I add 10,000 to both sides, then I'll end up with exactly this first expression. So these are the same expressions, just rearranged in different ways. So that's the first one. All right, so my suggestion is pause the video now, try to write 2 and 3 yourselves, and remember, define your variables accurately. What quantities are you interested in, and make sure that you define variables that stand for those quantities. Make sure you're communicating exactly what quantities your variables stand for. So pause the video now, and then we'll come back and look at the answers for 2 and 3. Okay, let's look at these. So for 2, well, the quantities we're interested in are the number of pencils Alice has and Bob has. So that's going to be the number of pencils Alice has, and B will be the number of pencils Bob has. Great. So let's go ahead and write this expression. So if Alice has twice the number of pencils as Bob, well, there's kind of 2 ways to go. Twice is double, so we'll have to multiply by 2. So let's see, is it 2a equals b, or is it 2b equals a? So it's going to be one of these two. And if you're not sure, it's a good idea to make the problem a little bit simpler. Pick numbers of pencils for Alice and Bob that make intuitive sense to you, and make sure that you're getting equality. So maybe we'll say that Alice has 20 pencils. Well, if Alice has 20 pencils and has twice the number of pencils Bob has, well, Bob must have 10 pencils. So which equation do we get equality? Do we get true equality when we plug in a equals 20 and b equals 10? So this is always a good way to test that what you're writing down is correct. So let's check. So the first one, 2 times 20, does that equal 10? It does not. 2 times 20 is 40. So this is no good. Let's check the other one. 2 times 10, does that equal 20? And it does. 2 times 10 is 20. So the correct expression for Alice having twice the number of pencils Bob has is 2b equals a, or a equals 2b. However you have it arranged on the left-hand side or the right-hand side, doesn't really matter. You can swap over left-hand sides and right-hand sides of equality willy-nilly, and it's no big deal. And the third one. So again, we're interested in the number of candies of Michael and Anna. So let's use M as number of candies Michael has, and A will be number of candies that Anna has. All right. I'm going to scroll up just a little bit so we can see the expression. So Michael has 10 more than triple the number of candies as Anna. So we can kind of, if we reword this, we can kind of write it down almost immediately. So if I say the number of candies that Michael has is 10 more than triple the number of candies that Anna has. Well, if I say it like that, that tells me exactly how to write this down. So The number of candies Michael has, well, that's M. That is, so is the same as, so I'll put an equals there. It's 10 more than triple the number of candies Anna has. So triple the number of candies Anna has is 3 times A, and then I need 10 more than that, so I'll add 10. So here's the expression for the number of candies Michael has in relation to Anna. So that's great. And maybe as a little aside, let's ask the question, if Anna has 8 candies, how many does Michael have? Well, all we're going to do is we're just going to fill in A equals 8. We're going to do that little substitution there and solve for M. So M, which is what we're looking for, is 3 times 8. Since Anna has 8 candies, we have this you can think of it as a very easy equation. All this is saying is that A equals 8. So we can substitute 8 in wherever we see an A. So we get M equals 3 times 8 plus 10, and you can check that this is 24 plus 10, which is 34. And it's always a good idea, if you're asked a problem in English and if you translate to math, it's always a good idea to give your answer in the language the problem was asked. So the problem was asked in English. Let's translate back to English. So we can say that Michael has 34 candies.